Insurance Facility and the World Bank. So during the course of the session, kindly remain muted through the presentations. And if you would like to participate in the Q&A session, you may either, for the audience, you may either enter your question into the chat feature. Yeah. If do take note that the session will be recorded. Okay, sorry about that. Sorry, okay, yeah. So just do note that the session will be recorded. Yeah. So before we begin the session, let me introduce who we are. SSTL is an independent organization that's based in Singapore, and one of our missions is to promote more meaningful use cases of advanced technologies from space. So this is why we started the HADR challenge in 2016 as a way to identify new and translatable solutions within the context of HADR. This year, we challenged our participants to develop a solution that will augment real-time flood extents derived from satellite imagery with flood depth information using available datasets and/or real-time data sources. We hope that through this challenge, we can better appreciate how technologies can better improve lives on Earth. So this year, we had a total of 26 teams comprising of organizations, startups, research groups, and even students from around the world stepping up to the challenge. And after months of hard work, we have narrowed it down to the top 4 teams who we will see pitching their solutions live today. Besides the 4 teams with us, we also have our panel of esteemed judges, Dr. Olivier Mahul, Global Lead and Practice Manager of the Disaster Risk Financing and Insurance Program at the World Bank, Mr. Bertrand Lesseau, Senior Scientist at the European Space Agency, Lieutenant Colonel Jason Tan, Deputy Director of the Changi Regional HADR Coordination Center, and Ms. Lynette Tan, Chief Executive at Singapore Space and Technology Limited. As a reminder for all our presenting teams today, you will only have 5 minutes for your presentation, followed by 5 minutes of Q&A from our panel. At the 4-minute mark, you will receive a prompt in the chat, and then we will cut you off at 5 minutes. So just take note of that. With that said, I think we can jump straight to our first presenters from Earth Analytics India. So Earth Analytics India Limited is based in Switzerland and is experienced in agricultural monitoring. The team comprises of Rama, an expert in rural technology, Sandeep, their remote sensing analyst, Gautam, a PhD candidate at Asian Institute of Technology, and Michael, the co-founder of Earth Analytics India. So I will hand over the time now to Earth Analytics, the team, to start their presentation. So Michael, whenever you are ready, your 5 minutes will start.
Great. Thank you very much, Jillian, for your kind introduction. I think I'm sharing my screen, so you should be able to follow my presentation, and then we can start. Thanks for having us. A pleasure to be here, and an honor to be selected among the 5 finalists. Now the slides don't move. Here we go. So we're actually from India. Most of us are in India, and also in Bangkok, Gautam, and myself, I'm actually the only one who's currently in Switzerland. So we took on this challenge that you put us in augmenting real-time flood extent with flood depth information and other sources by asking ourselves, what are the key performance indicators that we have that we want to take to make this challenge meaningful? What are the things that we need to watch out in designing a response to your challenge? We found it's very important to be original. So we're looking for additional insights by combining new technical products. We wanted to make sure it's affordable. So we primarily use publicly available data sources whenever possible. It needs to be deployed fast so that this is information that is readily available right after a flood event. And it needs to be scalable. So it's something that needs to work across geographies and not just in one particular satellite frame or smaller geography. So in responding to this, giving us these KPIs and responding to the challenge, we looked into various data sources. We looked into Twitter feeds, we looked into weather, traffic cameras, And we even looked into traffic data feeds from Waze or Google. There were, however, always some strings attached to it. So Twitter only had 2 or 3% of their feeds with GPS data. Traffic cameras, there was a problem with APIs, so we weren't able to get the data. And when it came to traffic data, it was a bit, there was more programming effort involved. So it was not so readily to be deployed. And also we didn't get this data for all geographies, or it was too costly when we talk about the Google solution. So eventually we found satellite data is the solution that we want to fully exploit. And we want to do that in 3 steps. First one is very straightforward. So we would use Sentinel-1 data and publicly available algorithms to map the flood extent. So I think that's pretty well-known practice in the industry. Second one is we use a flood depth model based on a digital elevation model from the Japanese mission ALOS Pulsar, historical data, which is freely available. And then we use then we want to understand what is the flood damage. And for that, we use, again, Sentinel-1 crop phenology monitoring and crop type differentiation so that we can understand at what crop stage is the crop when a flood hits to calculate any damage. So we looked for the first 2 elements. We looked into a real flood event that was hitting different parts of Asia. And that was obviously also hitting the Nakhon Ratchasima province in Thailand, which was the area we decided to focus on. So here we have our flood map marked in blue, marked in red, flood extent October 14, marked in blue, flood extent 1 acquisition later. So you can see how the flood is moving downstream the River Moon. We then calculated the flood depth. Here we used, as I said, ALOS Pulsar data at 12.5 meter resolution, a digital elevation model, which is slightly better than what is generally being used in the industry, SRTM elevation model, 30 meter resolution, but it can still be improved by using ALOS Prism optical data, digital elevation model. However, there is a small cost attached to it, so we didn't use that. We then inputted that into a publicly available open source flood model from the University of Maryland that we slightly adapted to derive the actual flood depth information that you can see here, which we validated with IoT devices, flood gauge data that we received from flood station in Nakhon Ratchasima province at this flood event from last month. We also used weather data just to be sure we're on the right track. So we used 2 weather data sources to confirm. Is this real-time flood monitoring? Probably not yet, because we still have only every 6 days the Sentinel coming around. We are exploring GNSSR technology, which is a technology that is used for the GPS system. It's not fully operational yet, so it's still R&D, but we are onto it to then actually have real-time flood monitoring. Now, last half minute, my last slide or our last step is to assess crop flood damage on crops. What we need for that is we need to monitor the crop phenology, again, based on Sentinel-1, and we did this in India, we didn't do it in Nakhon Ratchasima, to know when has which crop been planted in the season so that we know when the flood hits, at what crop stage is a particular crop in a particular geography, so that we can then assess the damage on the crop. And by that, I think I reached my 5 minutes. So we still have to validate our solution. We're talking to a reinsurer. We would like to validate it also with the World Bank disaster finance team. But we think we are on the right track. Thank you very much. Over to you for your questions.
Thank you, Michael. So we will now hand it over the time to the judges to ask some questions. For our judges, if you have any questions, please feel free to just unmute yourself and ask the team.
Good morning, good evening. This is Olivier Mau from the World Bank, one of the 4 judges, if I may start.
Bonjour, Olivier, sure.
One question I can appreciate, first of all, of KPIs, affordability, timeliness, scalability, originality, which is great. I will have had impact as well. I think it's important to have an impact at the end. One question, and again, acknowledging that I'm not an expert, is I can see it's a pretty complex topic as far as I understand, trying to combine flood as well as with crop assessment. I'm wondering whether one of the applications will be, first of all, to better understand how many people are impacted before you move into crops, and whether this is the kind of application that could be also quite helpful. Maybe easy to do, maybe quickly to do in order before you move into a kind of more complex ag assessment, which, as you said, can be quite complex here.
So you're asking how many people we would impact with that solution? Is that?
And whether your technology could allow exactly to allow and understand how many people will be impacted before you move into, you know, the impact on crops, which, as you said, it can be quite complex.
Yeah,
even more complex than assessing number of people impacted.
Yeah. So the impact we would do in terms of of course, the flood extent. If we cross the flood extent with the geographical information over that geography, we are building a dashboard. So once we have the dashboard ready, which will be end of next month, we would be able to have a geographical information for that particular geography. If we put the flood extent on it, we will know how many people simply by the population size will be impacted by that flood. We also, however, took from an earlier briefing we had, I think from one of your colleagues in one of the early webinars, we understood that also you have solutions where you want to understand the flood impact in rural areas. And that's why we brought in our experience from India, where we mapped crops in actually very complicated ecosystems. So if we look at the other Southeast Asian countries, the crop ecosystem is not as dense and complicated as in India, because you have a lot of rice and paddy, whereas in India you have many different crops. But that would give us a sense of the economic impact of the flood. So the people impact in terms of the flood extent, and overlaying it with the information of the villages affected or cities affected. And the second one would be the economic impact in terms of, is there actually a crop loss if we also map the crops in those geographies. I hope it partly at least addresses. Thanks.
We also have human settlement data from HRSL by Facebook Research, and also which is at like 10 meter and 20 meter resolution, like human settlement. So we can overlay like flood extent on human settlement data, which can in which you can determine like which area or like which locality having high risk. So we can set up the priority to those places. So high resolution human settlement data is available, and that can be utilized to estimate the number of people affected. That's all.
Yeah, thanks for that clarification.
Yeah, I just have a question here. Michael or Gautam, you could answer. But are you just using on the Sentinel data, or do you also augment it with the EO data from other satellites? And then you have those cameras and the Twitter feed. But what other satellite EO satellites are you using? It can be no others. Yeah. Just curious.
No, I mean, what we do have experience with TerraSAR-X, PAS, and CSK, all radar-based satellites from Europe that have very high resolution. So we also went through their procurement mechanism, but there are two challenges. One is an operational challenge, so you have to pre-order the satellite data, unless it's a very broad emergency, when there are mechanisms to make the data available. And the other challenge is that it's quite costly. So that's why we left it out we didn't present it as a solution here, but we have experience in ordering those satellite data. We also have experience in processing those satellite data, and we have excellent results. So particularly when it comes to flood mapping, of course, the quality of the data is excellent. But we, for the operational challenge and for the financial challenge, we didn't take it as part of our sort of kind of core solution. But they're very good data sets, no doubt. And there are other providers as well.
Thank you.
Sorry, you asked about the weather cameras and these things also. So we looked at these different like traffic cameras, Twitter feeds, but we discarded it for, again, very concrete operational reasons. So there are good solutions out there on Twitter, but they also have their challenges because most of the tweets are not geotagged. Traffic cameras I mentioned is challenging because APIs are often not available. So the only solution that we will further investigate and put on our platform will be so if you look at traffic data, you have Google traffic and you have Waze, and they indicate how blocked roads are. Now, Google is not easy to get. It's quite costly. So they have a commercial solution for that, but it's costly. But Waze data is available. So we looked into getting Waze data. There are some issues because Waze is more available in some countries and less available in other countries. So there's an issue about scalability. And since I put these strict KPIs, we won't be able to use Waze data across these geographies that you mentioned as being of your interest. That's why we put it in sort of second rank and second priority in implementation. But we want to, once we have our platform running, I mean, this is something we can do without a platform, the solution we showed, but once we have a platform running, then we will try do a trial and include Waze data as well.
Thank you, Michael. So that's all the time we have for your team. We have to jump to our next team now, which is Team SAR. So SAR leverages on advances in satellite remote sensing, machine learning, and big data analytics to provide answers to large area questions across multiple domains. Presenting today, we have Sarvesh Green, the Vice President of Value Engineering at Team SAR. So Sarvesh, I'll pass the time over to you. You can share your screen and start your presentation whenever you're ready.
Perfect, Jillian. Thanks a lot for the introduction. I'd just like to mention I'm also accompanied by Rashmit, who is the CTO at SAR. So please allow me to share my screen. Again, thanks a lot for the opportunity today.
Yes, so just go ahead and share your screen.
Perfect. It's visible, right?
Yes, but you might want to put your presentation on full screen.
Yeah, I'm just doing that.
Yeah.
Thanks. So like Jill mentioned, we are essentially a digital intelligence company, like we like to call it. And within this challenge, we have put forth the solutions which we have been successfully pretty much implemented in cases of disaster, and also assisting disaster infrastructure, property insurance use cases. Talking about what we do, if we look at the problem statement, we all know the global population is pretty much exploding, the amount of cost losses due to disasters, and how exactly we are all looking to get some good solutions to tackle the disasters and create some good mitigation solutions around it. So what we do at SAR is pretty much we're trying to solve the data problem through different sources. We all know in pretty much developing countries in Africa or Southeast Asia, the accuracy of the data is pretty dubious. The entire process of accumulating the data is unstructured, is expensive, and overall it's laborious and difficult to understand. So that is where our technology comes into picture. The entire technology stack, which is called SAR Sparta, is sensor agnostic. That means we can ingest data sets from any sensor, be it satellite, IoT, weather, drone, econometric data sets. We have the proprietary algorithms built in, which essentially gives us the insights, and we use these insights in a 3R strategy. The 3R strategy is reaching the right places or right areas at the right time with the right plans. This is the overall approach that we have. Talking about the impact, focusing on just Kerala flood solution, which we did for the government of Kerala in India in 2018. There were around more than 12,000 people rescued during that implementation, which I will just elaborate overall later. Our solutions are pretty much appreciated, and we have called global recognition to large organizations like ADP. We have recently been a part of the World Economic Forum, and recently we signed an MOU with AXA Climate to basically deliver parametric solutions for agriculture infrastructure. So talking about the solution, we have divided the solution into pre-event, during event, and post-event analysis. In the pre-event analysis, we pretty much get into the risk zoning, getting with the help of the historical data to help create risk triggers based on the forecast that we get from weather data sets, and then help the authorities, whether it's government or private organizations, to create the mitigation strategies. During the event, it is basically continuous monitoring, not just with satellite imagery, but with alternate data sets. It can be emergency calls, it can be social media analytics. So all this data we take into account and then create a real-time dashboard, which takes into account the dispatches, the resource monitoring, the resource utilized by the organization to help them keep a track of the overall event. And post the event, it is basically a damage assessment and a rehabilitation planning that we take into account to help the organizations. So overall, it's talking about the exposure, we have pretty much covered such solutions for pan-India basis by combining different events. This is a use case that we did for Kerala government, like I mentioned. This was in collaboration with IBM. where we got the analysis of the flooding extent, the depth of flooding through the DEM models, combining it with the problem that government was facing was due to backwaters in the state and this proximity to the Indian Ocean. Arabian Sea, basically, it was basically very difficult for them to locate where exactly people are stranded, and that is why. Pardon? Okay. That is why we have to basically rely on other data sets, which also took into account the emergency data sets. And overall, within a span of 7 days, the government were basically able to rescue more than 12,000 people, which in itself was a great achievement for us as a private organization. Taking this solution beyond disaster management, we have created a insurance lifecycle management system as well, where we both help in the insurance product creation, then claim settlement solutions, as well as a portfolio monitoring solution for the insurance sector. Like Michael pointed out, beyond agriculture, we are basically also taking this solution to the infrastructure and the property insurance sector as well, because there's a monetization part which comes into picture. And the disaster being an event where we basically cannot wait for the disaster, we have to take the solutions to more life cycle oriented approach. So that is why we basically have taken the solution to the insurance sector as well. Overall, about the delivery model, it's pretty simple. We deliver the solutions at dashboard as well as mobile applications for the field staff to basically create plans and reach the locations in the right time according to right plans. And that's about it. Talking about the team, we have founders, pretty much a team from the remote sensing, diverse sector remote sensing, data scientists, and data agriculture experts. Thank you. I'm open to questions from you guys. Thanks a lot for the opportunity to present.
Thank you, Sarvesh. So for our judges, please feel free to ask the Debsure any questions you might have.
I have a question. So actually you talk about how you have 3 different parts, which is a pre-event, then during the flooding, and then post-event. So the challenge here actually is really in the real-time data that we can get. Could you perhaps elaborate more on the real-time capability of what you are trying to provide, and maybe give a little bit more information about how that can be intuitively utilized?
Perfect. So, see, real-time data is always a problem during disasters, because we all know the entire infrastructure basically goes to a toss. So we have to rely on alternate data sets. So one of the approaches that we have is obviously taking into account satellite data and drone data. Apart from that, the alternate data sets that we take into account, I have been successfully done it in our previous work with the government, is again the emergency data, the SOS calls which people who are stranded make. So we take those data sets to create pin code level zones, risk zones, depending upon the population density of the human settlement and the overall geography in that region. It can, whether it's the proximity to a natural water body, its proximity to forest, and what is the overall DEM model. So this helps in creating risk zones, and depending upon the risk zones in real time, then we help create a rescue plan for the government.
Okay. Thanks.
Okay.
If I can ask a question about, I mean, you are targeting the insurance market, which is a very, very good idea. But this kind of customers are very interested in high precision products. So my question is about what kind of precision do you expect to have on the, especially with the data that you mentioned before, if you think that it is reachable?
Right. So again, like Michael from Earth Analytics pointed out, for this solution, we have taken into account the public data sets. We also predominantly rely on Sentinel data. Again, like I mentioned, the solution has been distributed in a pre-event and post-event analysis, right? So in pre-event analysis, a public data set at a 10-meter resolution, along with the weather data sets, both real-time and forecasts, are more than sufficient to essentially create risk zones, combining with the historical data. Let's say we have NatCat models, we have the historical 2 to 3 years of satellite data. These, along with the public data sets like human settlement data, the overall landscape in that region. these are itself pretty much good enough to help create risk zones if we talk about insurance sector. These risk zones are then utilized by the insurance companies to basically create customized parametric solutions for the regions. And like post the event, if at all there's a requirement of high resolution data, yes, we do get into processing the high resolution data as well. But if at all it's not required, if it can be done with the public data set, we pretty much do the analysis of public data set.
Okay.
Rashmit, just to add what Sarvesh said, satellite data gives you the good indicator in a region, as in where to look for. And what we do is, depending on the requirement, we acquire the high resolution data in those pockets to go more granular and give more granular information in that particular region.
Hi there.
Hello.
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 This is Shastri here from AXA Climate. I have a follow-up question to what Mr. Bertrand has asked earlier. You mentioned you would use Sentinel data, but how about the reconciliation of temporal resolution? It is not captured, as far as I understand, it is not captured on a daily basis. And in particular, some of the Southeast Asian nations, they are very much affected by flash floods, which last for only few hours. So how do you account for this differences in temporal resolution?
Sarvesh, can I answer? Yeah. So what we do is, as in when we take the satellite data, we also run the simulation model in between. So, for example, there are two. There's a for Sentinel data comes at 10-day revisit. So to generate the intermediate data, we take into account rainfall, we take into account depth, slope, aspect, all those parameters to run the simulation to generate intermediate data. So that gives you the most probable locations where the flooding would have happened. And the rainfall data, what we have is, it's on a daily basis. So based on that, we generate our models. It's more of a simulation to fill up the gap between the two satellite data. That way, there's no left or gaps in between. And as you mentioned, it will also capture the flash flood, which are there for like 1 hour, 2 hours, that way.
Have you considered using MODIS data, which is having a better temporal resolution, more or less on a daily basis, with the
yes,
Sentinel data?
Yes, sir. We did consider MODIS data, but the major problem with MODIS data, it has like it's an optical data, but and
Yeah.
top of that, the pixel resolution is very big, 250 by 250 meter. But what Sentinel data provides you is a 10-meter resolution. That way, what we do is we take the same spatial reference and we do that all the upscaling based on that. So it's a good reference point that way, and it helps us to provide more granular information compared to MODIS.
Okay, so thank you for the Q&A. So just a reminder to the audience, our Q&A is only reserved for our judges. If you really have questions that you would like to ask the teams, please feel free to type them in the chat. And then if we have some time left at the end, we can try to address some of the questions you may have. But yes, so unfortunately, time is up for teams at SURE. So we have to move on to our next team, which is Team Synspective. So Synspective provides a one-stop solutions by satellite data and other geospatial data, and they produce SAR data for both government and commercial clients, as well as provide user-friendly information and insights from satellite data across industries. Today we have with us the team members Shiori and Adam, who will be giving their presentation. So Shiori, please feel free to share your screen and you can start your presentation whenever you're ready.
Thank you, Gillian. So 1 second. Okay. Hi there. Thank you for attending to our session. I am Shirley, a customer solutions engineer of Synspective. Today, we'd like to introduce our flood monitoring service. We contribute to quick disaster response and help user decision making. Let me briefly introduce what we do. Synspective is a Japanese startup, and we are based in Tokyo. and developing small SAR satellites and we build a SAR satellite constellation to produce frequently updated data and the user-friendly information for customers as a one-stop geo-solution provider. Here's the overview of our FLAG solution. You can save time to get disaster information, and it's easy to share the situation with staff. This will be useful to estimate the damages, give priority, and conduct the rapid needs assessment and personal deployment. This will be helpful, especially for government, disaster response agencies, and non-life insurance companies. Here is how the information is provided. You can see damage information, flood area, flood depth, the length of affected roads, and the number of affected buildings on the dashboard page and map page. This solution is now available with Sentinel-1 data. Service fees charged according to the area you want to see. Users access to the website and sign in with their ID and password. You don't need to purchase the data, analyze the data, nor install the software. Here is the platform of our flood monitoring. If you want to see the content individually, you can hide each content by clicking the icon, and we can change the base map from dark map, street map, and optical imagery on the platform. And to share the disaster situation with stakeholders, you can export the summary in PDF format from the lower left button. PDF is downloaded and you can export and report the disaster damages. And main benefits of our solution are reliability, wide area range, and high frequency. The satellite imagery are used for flood damage assessment, and it's capable to observe the ground under bad weather in a large area at once. Satellites visit a point bi-weekly at this point, and daily observation will be available with low cost, with respective constellation soon. In the disaster situation, heavy rains continue over days to weeks in a large area, and it takes time to understand where it's seriously damaged. Our solution is available anywhere in the world in all weather at day and night. Immediate damage assessment can be provided within a few hours after the observation. This will be useful to estimate the damages, give priority, and conduct a rapid needs assessment and personal deployment. In your operation, our solution can be utilized at the phase of disaster damage assessment, rapid needs assessment, and risk management. Based on the information, you can plan the support and help the local government and organizations. In terms of technical features, hybrid methodologies apply to improve the accuracy when flood area is detected, and flood depth is estimated based on the flooding area with them data. Improved algorithm helps us to properly understand the situation. Here is one case studies of flood damage assessment. We have estimated flood extent by our own improved algorithms, and flood extent in urban areas can be detected. In general, flood extent is underestimated due to soil reflection characteristics, and inundation area in suburban areas are detected. We are still improving the detection algorithms, and the upgrade is to be applied for the solution. So existing software can revisit bi-weekly, and historical data is archived to compare with post-disaster images. In addition to existing satellites like Sentinel-1, TRSAT, Cosmos SkyMed, SISPEC is now developing the own SAR satellite constellation to produce daily updated data to improve time resolution. 30 satellites will be in orbit for daily monitoring in the world. This data will be used in our solution, and more frequent information will be provided as per users' request. So here is the summary of our SWOT solution. Remarkable points are its accuracy, accessibility. Thank you for your attention. If you have any questions, yeah, feel free to let me know.
Thank you, Shiori-san. So for our judges, your 5 minutes to ask questions for Synspective can start now.
It wasn't clear from your presentation because you mentioned about the satellites and the frequency of the revisit, and they didn't seem too frequent. You know, it's in weeks and days. So how is that going to be able to present real time, data on the flood extent?
Flood extent is automatically processed on the platform. So once Sentinel-1 data is observed, we can download automatically and we will process the data and upload on the platform. So users only need to access to the website with ID and password, and you can see the disaster information.
And then you can't control the reposition Sentinel, right? But then you probably would be able to do that for your own satellite that you will launch next year.
First satellite is to be launched, next week. And we will deploy 30 satellites in orbit.
Well, good luck with the launch.
Thank you. Yeah, at this point, we are using Sentinel-1 data. It's bi-weekly observation, but we can also use other satellite data, SAR-X, Cosmos SkyMet, Kayrros 2, if needed. And we will add, our satellite data.
Hi, sorry, this is Jason. I would like to ask about your assessment. Just now you spoke about you need a few hours to do the assessment. So what kind of assessment you'll be doing? What kind of resolution, like probably those type of road that is blocked, or the depth of the population affected, or what kind of resolution that you're looking at? The assessment that you talk about a couple of hours after the disaster hit?
Yes. The spatial resolution depends on satellite data. At this point, we are using Sentinel-1 data, so the resolution is 20 meters resolution. But if we use SAR-X or our own satellite, 3 meter resolution is available.
3 meter resolutions. Okay, thanks.
Thanks.
So thank you for this presentation, which was very complete. So to build up on my partner's question, I would have one on how, SAR data is known to be very noisy in urban areas. So you propose to have some very good mapping also in urban areas. So could you tell us a bit more about how you make this possible?
Yes, exactly. SAR data is tricky to use. So we use hybrid methodology, and we use both information, intensity and phase information. Firstly, we calculate a coherence between post-flood disaster and post-disaster. And then, in addition to detection by coherence, coherence difference, intensity differences are considered as the affected area. By using both information, we can reduce the noise, and by comparing the intensity of pre-disaster images with post-disaster imagery, increasing and decreasing are used.
Okay, thank you.
Thank you.
Okay, we have time for one more question if any of the judges have. follow up? Otherwise, no. Okay. We can move on to the next team then. So our last team presenting for today, we have Team Kayrros. Kayrros is an advanced data analytics company that sets out to help traders, investors, operators, and governments make better decisions through insights obtained by integrating satellite imagery, unconventional data, and market information on a global asset observation platform. The members we have with us today are Oscar, Thomas, and Ahmed. So Ahmed, I'll hand over time over to you to start your presentation, and you have 5 minutes.
Thanks, Jillian. So I'm going to share my screen. Okay, so hello everyone. I'm Ahmed Lalou. I'm a data scientist at Kayrros. We specialize in extracting insights from geospatial data. Today I'm going to present to you a solution to monitor floods directly from space. So let's start. Here is our solution. Our pipeline relies on 3 technologies: 3D reconstruction, hydraulic modeling, and radar image analysis. On top of that, we also use additional data sources such as hydrometric data, infrastructure, and population data. So we will get back to this timeline later, but first let's have a look at each one of these technologies. So first, the 3D reconstruction. It's very important to estimate the depth of the water during floods. So as you can see on the animated picture in the left, we use 2 high-resolution images taken at different angles to estimate the height of each point in the area. Thanks to that, we are able to produce a high-resolution 3D model that you can see on the second picture. It's only at 80 centimeters. And with the help of a second algorithm, we can detect ground points and remove buildings from the model to produce a ground model. So the ground model is very important for the hydraulic modeling. Once we have the hydraulic model and the real-time hydrometric data, we can use the HAN model. The HAN model is a hydraulic model that can deliver fast and accurate results. Thanks to that, we are able to produce a high-resolution flood map that you can see on the picture below that has the depth information. The next step of our pipeline is SAR image analysis. So when there are floods, in general, there are also a lot of clouds. But thanks to this technology, we are able to take picture in any weather conditions. So this technology works by doing change detection over 2 or more SAR images to detect water. So we can see an example of that in the left, where the white areas are the parts where water is detected. This works in both rural and urban areas, unlike what's available in the market. We can also use other data sources with the 3D model, such as the ground sensor data and the social media. So now I'm going to share with you some of the results that we get on Derived, a city in France that was flooded during 2018. We backtested our results against ground truth data delivered by public authorities, and we achieved more than 91% accuracy. So here is the 3D model of the city. Please keep in mind that the resolution may be decreased due to the video call. So the first step of our pipeline is to model the ground, which you can see here. Once we have that, by using hydrometric data, we can create a 3D flood map that you can see here. So this flood map is generated by hydraulic modeling and corrected by the SAR image analysis. We can plot that directly on the city. So let's zoom on this area. Thanks to OpenStreetMap, we can have detailed information about the infrastructure. So in here, we can see that we are looking at an industrial area next to railways. And by combining this information with the 3D depth, we can directly visualize the damages on these parts of the city. So we can see that here. So we can see that this group of buildings is affected by the flood. And thanks to the precision of our flood map, we can see that this group of orange buildings is more affected than the yellow building just next to it. Another important part of damage assessment is the population. So thanks to Kayrros' expertise in GPS data, we are able to estimate the local density of the population in the city by using smartphone data. And with the help of clustering algorithms, we are able to isolate a group of people that may be endangered by the flood. So in this example, we can see that we have two large group of people right in the middle of the dangerous area of the flood. So here is the timeline of our product. So the 3D reconstruction is made available before the start of the event and can be therefore used for risk management by doing multiple scenarios on the height level of water. Once the event occurs, thanks to the real-time hydrometric data, we can do a real-time hydraulic modeling on the 3D model and have first results right away. And at most 24 hours after the start of the event, we can acquire the SAR images and improve the results with the SAR image analysis. So that's it for our solution. Thanks for your attention, and don't hesitate if you have any question.
Thank you, Ahmed. So our judges, if you have any questions for the final team.
No, thanks. So it's very, very nice presentation. One question, if you could elaborate, please, a bit further on the damage assessment for population. You mentioned the use of smartphone data. Can you just elaborate a bit more on that?
Yeah. So let me get back to the slide. So we use geolocation data to estimate basically how many people there are in each road of the city by using data collected at night, for example, during a larger period of time. And by doing that, we are able to estimate how many people there are exactly on each building, for example. And by combining this information with the flood map, we are able to see how many people are in the dangerous area of the flood.
Hello everyone. I'm Oscar, working with Ahmed. Are you actually familiar with the GPS data coming from smartphones? So it's a data that is collected by data aggregators when people actually accept to geolocate themselves using their smartphone, and the data aggregators then sell this data to people like us or other players doing marketing, for instance. So we get this data every morning for the night before, basically, just to give you a bit of a timeline.
So I have a follow-on questions to this smartphone thing. So is it real time or is after a few hours of assessment?
So this data is actually collected before the event, so it has to be ready before the event. So that's when we have the flood map, we can directly count the number of people that are in the area.
All right, thank you.
Yeah, and this is basically when you want to do density maps, but as we have access to this data, the morning after, we can also have a look at a pretty highly accurate view of the number of people that are exactly within those places, basically a couple of hours after.
Okay. And if I may, maybe a follow-up question on that. In terms of costs, I mean, it looks very interesting, very impressive, I must say. How about the cost implications if you were to scale up, particularly in developing countries?
That's a very good question, actually. The whole point of this methodology is we wanted to do the product that was the most precise as possible, using every kind of high resolution data available. So you've seen that for the 3D modeling, we're using satellite images that are of high resolution. So this has a cost, of course. Then using SAR images and doing change detection between SAR images, we've done it on high resolution images. Then, looking at this very high precision, then we can downscale any kind of those models. If you want to downscale the 3D model, we can go back to what's available off the shelf, back to almost free data that is at 10-meter resolution. And so you got a lot of options, to downscale it, depending on basically this couple, which is risk and value associated with the zone. And we wanted to prove the precision of our technology on super highly dense urban areas, so that then we can show that we can downscale the technology and do it in rural areas where we don't need this kind of precision, basically.
We have time for one more question for the team.
So maybe I have so also a short follow-up, because I guess this GPS phone part is very interesting. Do you plan to have an app, a phone app that people are downloading and can activate, or do you aggregate data from all smartphones by buying it from a provider?
Yeah, no, it's a good question. If you want to get to a coverage of people that is above 5 to 10% of the population, you can't make people download apps. This is not viable. So basically, the data aggregators that we use the data from actually collecting from a lot of different apps, and then to reach this kind of coverage. To give you an example, in the US, there's around 25% of the population that is covered using this kind of data. So it's of course based on a lot of different apps. Okay, thanks very much. The spatial resolution is around can go down to a couple of meters.
Okay, great. Thank you.
So that is all the time we have for the teams today. Thank you very much to our 4 shortlisted teams for the wonderful presentations, as well as our judges for the time and their questions that they've asked. For our audience, if you have any questions for the teams, I'm sure they will be happy to answer them via email. You can feel free to reach out to them through the chat to get more answers. But yes, so for our judges, the results will be released to our participants before the end of the month, so in the next 2 weeks or so. But yes, so thank you everyone for your time today. That's about all the time we have left. So thank you, everyone.
Thank you indeed. Goodbye.
Thank you.
Bye.
Of course, if any of our judges who are still here, if you have a question, we do actually have like 2 minutes before the room is closed. Feel free to ask any of our participants who are still here as well.